Hello and welcome. Today we are getting down to the absolute fundamentals. We're looking at the two main ways that we've been shaping metal for literally thousands of years to build, well, just about everything around us. We are talking about casting versus forging.
I mean, really think about it for a second. That engine in your car, the landing gear on a plane, it all starts out as just a lump of raw metal. So how on earth do we transform that into something so precise, so strong, and so purposeful? Well, it all boils down to one simple choice.
And this is it right here. You really have two fundamental paths you can take. On one side, you can melt the metal completely, turning it into a liquid and just pouring it into a shape. On the other side, you can heat it up so it's glowing hot and pliable and then literally hammer or squeeze it into the shape you want. It's the ultimate difference between flowing and forcing, and that one choice changes absolutely everything about the final part.
So first up, let's head down the path of liquid metal and explore the incredible ancient art of casting.
That's right, you heard me correctly. 6,000 years old. We are talking deep history here, back to the earliest civilizations. And you know, the core idea is just as brilliant today as it was then. If you want something made of metal, first make a hollow version of it, that's your mold, and then just pour liquid metal inside. It's kind of like making Jell-O, but, for industrial engine blocks.
To really get a handle on how this works, we're going to walk through one of the most classic and widely used methods out there, sand casting. It pretty much breaks down into these 4 key steps.
Okay, so step 1. It all begins with a master copy. This is called the pattern, and it's an exact physical replica of the object you want to create. It's often made from something like wood or plastic. Every single detail of the final part has to be perfectly captured right here at the very beginning. Next, you take that pattern and you press it into some very specialized, tightly packed sand. You usually do this in 2 halves, which are called the cope and the drag. Then, when you pull that pattern out, what's left behind is a perfect negative impression. That hollow space right there, that's the mold cavity. That's where the magic is about to happen.
And here comes the really dramatic part. You heat the metal in a massive furnace until it's completely molten, and then you pour it into that sand mold. The glowing liquid metal flows through all these carefully designed channels and fills up every single tiny nook and cranny of that cavity. So once the metal has had enough time to cool down and become solid again, you just break the sand mold apart. And what's left inside is the raw metal part, now in the exact shape you wanted from the very beginning. It'll need a little bit of cleaning up and maybe some machining to get the surface nice and smooth, but essentially, it's ready to go.
Okay, so that's the path of liquid. Now let's do a complete 180 and explore a totally different philosophy, the path of force.
Forging takes the exact opposite approach. Instead of melting the metal, you just heat it up until it's glowing red-hot and malleable. But here's the key, it's still a solid. Then you use truly immense force, either from a giant hammer or an incredibly powerful press, to squeeze it and shape it. Just think of a traditional blacksmith, but scaled up to an epic industrial level.
The principle here is really direct. You take a heated block of metal, that's called a billet, you place it between 2 shaped tools, those are called dies, and then a super powerful ram comes down and presses them together. This literally forces that hot, soft metal to flow and take on the shape of the dies.
But that basic idea can actually be done in 2 very different ways. And the main difference, well, it all comes down to the design of those dies.
And you can see the difference crystal clear right here. On the left, we have open die forging. This uses simple, often flat dies to just kind of squash and shape the metal. It's perfect for making really huge, simple shapes, like a massive shaft. But then, look over to the right. That's closed die forging. It uses dies that have the final, precise shape carved right into them, so they completely enclose the metal and create a much more detailed, almost finished part.
All right, so we've seen the 2 paths. Now it's time for the main event. Melt versus hammer. Let's put them head to head.
I mean, this is the big question, right? Why would an engineer pick liquid metal over brute force, or the other way around? What's the trade-off here? It all comes down to what you need that final part to actually do.
And this is where the real decision gets made. Here's a good rule of thumb. If you need a crazy, complex shape, you're going to cast it. Because liquid can flow into almost any geometry, you can create these incredibly intricate parts that would be impossible to make any other way. But, and trust me, this is a big but, if you need a part that absolutely positively cannot fail, you forge it. The intense pressure of forging actually refines the metal's internal grain structure, making it unbelievably tough and strong. Now, of course, there's a cost trade-off. Forging usually gives you a smoother part right out of the gate, but those specialized dies are really expensive, so it makes more sense when you're making thousands of the same thing. Casting is generally cheaper for one-offs or small batches, but you usually sacrifice a bit of that top-tier strength.
So you might be thinking these techniques sound kind of old school, and you're right, they are ancient. But don't let that fool you. They are the invisible backbone of our entire modern, high-tech world. Seriously, from the simplest tool in your garage to the most advanced spacecraft, pretty much every critical metal component out there began its life either as a liquid in a mold or as a glowing hot billet under a hammer.
When failure is simply not an option, you're looking at forging. Think about the parts that have to handle the most incredible stress imaginable: the spinning turbines inside a jet engine, the crankshaft and connecting rods in a high-performance race car, or critical structural parts holding an airplane together. Their amazing strength comes directly from that forging process.
And on the flip side, when what you really need are complex, intricate shapes all made in a single piece, you turn to casting. Think about a car's engine block with all of its internal channels for oil and coolant, or the complex body of a pump or a valve. Casting is really the only practical way to make these kinds of sophisticated shapes efficiently.
So there you have it. Liquid or solid, melts or hammer. Two ancient paths that have literally taken us from the Bronze Age all the way to the Space Age. And it really makes you wonder, as we keep developing new alloys and facing brand new engineering challenges, what incredible things will these fundamental processes help us build tomorrow?